True students, I'm back. I took a little bit of a break. I think my last video was back in August, and here it is. It's November, and we're ready to start a new batch. I'm in section 4.7, and I'm going to start with example 1. Our goal is to talk about a different kind of proof called a coordinate proof. So let me box this in for you right here, and that's a really thick, fat line. You know I don't like them quite that thick. Let me lower that. But a coordinate proof is a style of proof that uses coordinate geometry and algebra together. The first step of a coordinate proof is to position the given figure in the plane. You can use any position, but some strategies can make the steps of the proof simpler. And that's what we're going to talk about right here. These are the steps that I want you to take a look at. Let's say you're working with a polygon, a four-sided polygon. It could be a rectangle, a square, something like that. What you could do is use the origin as one of your vertices and keep that figure in quadrant 1. You can center the figure at the origin. You can center a side of the figure at the origin, or you can use one or both axes as a side of the figure, which I like that one a lot. I really do. Now, if you look at example 1, positioning a figure in the coordinate plane, this is what we're kind of practicing right now. They're saying position a rectangle with a length of 8 units and a width of 3 units in the coordinate plane. Method 1, it's okay. It's not my favorite. I actually like method 2 a little bit better. Method 1 says you can center the longer side of the rectangle at the origin. So they took this side, this 8 units, and they put 4 units to the left of the origin and 4 units to the right. And so the origin is the central point there of that long side. So that's a way of positioning it. I really like method 2. I don't know why I'm drawn to this, but I do like to use the origin as one of my vertices, and I like to also use one or both axes as sides of the figure, as you can see here. So the width of this rectangle is actually, 3 units, and I'm using the y-axis for one side, and I'm using the x-axis for the long side, and one of my vertices is actually the origin. So I'm using a couple of the strategies for positioning this figure in the coordinate plane. This is going to come into play, maybe not this particular example, just trying to teach you how to put a rectangle or some figure, give you some strategies how to position it to make the algebra a little bit easier. So this is really going to come into play in example 2, okay? So here's something, if we look at the bottom, depending on what you're using the figure to prove, one solution may be better than the other. For example, if you need to find the midpoint of the longer side, use this first solution. If that's what the problem's asking you to do is find the midpoint, then of course method 1 makes sense. If you're trying to find the distance of a side, I certainly would try and position it along the axes, or if you're trying to find the area, I would do it along the axes and just count the boxes, or if I have to find the length of the diagonal, just try to make it as easy as you can, and that's why positioning is so important. All right, here's your extra credit on your own piece of paper, because I don't have any paper for you. Let's do a little bonus here. This time you're going to do a right triangle. You're going to position a right triangle, and we have, we're going to do 2 legs, and one of the legs is going to be 2 units, and the other leg is 4 units. And position that on the coordinate plane, okay? And your hint, use the origin as the vertex of your right angle. So there's your hint, and we'll check that in class tomorrow. Thanks for listening.